Alright, so now looking at our second example, g of x equals x squared minus 4x plus 3 over x plus 1 quantity squared. Let's start off on this one and factor. So our numerator, we have, there we go. Okay, so the factors of 3 that add to be negative 4 are x minus 1 and x minus 3. All over our x plus 1 squared. So nothing's going to cancel. Our first step, remember, is our symmetry. And here, notice we have an even and an odd exponent. So right off the bat, we know there is no symmetry. Second, we're going to look at our x-intercepts. So if we set our numerator equal to 0, x minus 1 equals 0, tells us we have an x-intercept at x equals 1. And x minus 3 equals 0, tells us we have an x-intercept at x equals 3. Now let's look at our y-intercept. So here, because we have one that's factored and one that's not, let's just go ahead and use our factored form. So we have 0 minus 1 times 0 minus 3 over 0 plus 1 squared. So negative 1 times negative 3 over 1 squared. Negative 1 times negative 3 is 3, and 1 squared is 1. So our y-intercept is 3. On this one, we don't have anything that cancels, so we don't have any holes. We are just going to have a vertical asymptote. So if x plus 1 equals 0, that tells us our vertical asymptote is at x equals negative 1. And notice, since we have degree 2 here, okay, that tells us that we have a multiplicity of 2. And we talked about that being like a volcano, either going up or going down, depending on the shape of the rest of our graph. So once we start graphing, we'll see that. And then our last thing we need to find is our horizontal asymptote. So if we look at the degree of our numerator, it's 2. And the degree of our denominator, if we were to factor everything, or sorry, not factor, but FOIL this out, we would get x squared plus 2x plus 1, so that degree is 2. And those are equal. So we look at our leading coefficients, so y equals 1. Alright, so now if we want to go in and graph it, we have no symmetry. We have an x-intercept at 1. We have an x-intercept at 3. We have a y-intercept at 3. Then a vertical asymptote at x equals negative 1. And a horizontal asymptote at y equals 1. Alright. So, now we need to figure out, like, let's see here, let's start on the left side of our vertical asymptote. So we need to figure out, are we going to start our graph up here or down below? Since there are no x-intercepts here, we know we have to start up top. Okay, so our graph is going to get close to this horizontal asymptote without touching it, and then go up to our vertical asymptote without touching. Okay, now since we're at that vertical asymptote, this is where that multiplicity is going to come into play. Okay, so since we're already up at the top, that means we're going to volcano at the top. And that's going to allow us to go through that y-intercept. Okay, so this is a case where our graph is going to actually cross through a horizontal asymptote, which is fine. Usually that'll happen only once, but since we know we have to go through to that x-intercept, it's going to happen. Okay, so we're going to cross through at the x-intercept because we have that multiplicity of 1. We learned about that in our last unit. So that's going to cross through. And then x equals 3, we're going to also have a multiplicity of 1 and cross through. So this is going to come down, come back up, and then not cross that horizontal asymptote. Okay, so this one's a little different. That's why I added it, just to show you. Okay, we haven't talked about one where it crosses through that horizontal asymptote. That's okay. Remember, we can cross through horizontal asymptotes, but we can never cross through a vertical asymptote. Okay. All right, and our last one. So f of x equals x squared plus x minus 6 over x minus 3. So let's start off with factoring. So our factors of -6 that add to be 1. And that would give us the quantity x, let's see here, plus 3 and x minus 2 over x minus 3. So again, we're going to have no symmetry because we have a quadratic up top. Okay, if we find our y-intercept, plug in 0, we can, remember when we plug in 0, we can just look at our constants. So we have -6 over -3, which reduces to just be 2. Our x-intercept, so since we already factored, we can just look at our numerator. X plus 3 equals 0, which tells us the x-intercept is x equals -3. And if x minus 2 equals 0, our x-intercept is positive 2. Oops. How about not 3? How about 4? Okay, vertical asymptote. Looking at our denominator, x minus 3 equals 0. Tells us we have a vertical asymptote at x equals 3. And here it's multiplicity 1, so we're not going to volcano, like we did on our previous one. And then horizontal asymptote. The degree of our numerator is 2, and the degree of our denominator is 1. Since the degree of the numerator is greater than the degree of the denominator, there are no horizontal asymptotes. But since the degree of the numerator is 1 more, then the degree of the denominator, I'm just going to put that on the graph, there is a slant asymptote. Okay, so for slant asymptote, remember that's when we're going to do synthetic division. So where we have our trinomial, we just take our leading coefficient and then the coefficient of our second and our constant. And then if x minus 3 is in our denominator, that means we're going to put 3 on the outside, drop down our first number 1. 1 times 3 is 3, and then add 1 plus 3 is 4. And then we can finish this out if we want, but remember we don't care about this remainder column. And so our slant asymptote is y equals 1x plus 4. So that means we have a line with a y-intercept of 4 and a slope of 1. All right, so if we want to graph this, we have our y-intercept of 2. We have an x-intercept of -3 and +2. We have a vertical asymptote at x equals 3. No horizontal asymptote, but we have the slant asymptote. So we're going to go up to 4. And we have a slope up 1, right 1. And we're going to make our dashed line for that asymptote. Okay. So we know we can only go through points, so that means we're going to have to start in this section down below. So we're going to come up, go through that point on the x-axis, through the y-axis, and back down through the x-axis. And then since we have multiplicity of 1 on this vertical asymptote, and there's no points on this x-axis over here, that means that our graph is going to jump up here to the top, and we're going to make a little swoop at that top part. And there's your graph.